All right, questions, problems, concerns? Always. Everybody got their SLP turned in? So do you want to talk more about the thread aspect of TA5? Because that seems to be challenging. Side comment I just want to mention, because I saw this a bunch in code. Really good habit to get into. Make sure your class names are uppercase. Make sure your fields and variables start with a lowercase letter. Okay? It's a really adhered to convention. The compiler doesn't care, right? But anybody trying to look through your code will definitely stumble if they see something starting with an uppercase letter and it's not a class name. And if somebody's trying to work with your code, right, it slows them down. If somebody's trying to assess your background and experience by looking at your code, right, it's definitely going to raise mental eyebrows. So it's just a convention. Compiler doesn't actually care. So let's write some code, and we're going to replicate this on both the client side and the server side and see what happens. Alright, so ServerSocket accept a connection, get the input and output streams from that, use that to construct a scanner and a print writer. So get the next line. Print out what we got. No. Okay, so we're going to read from the keyboard. We're going to send it to the socket. And then So what do we got here? We've got the start of something which reads from the keyboard and sends to the socket. So it lets me type, sends it over, lets me type, sends it over. You want two-way communication. You also want to be reading from the socket and displaying that, right? So so let me be a little more careful about these names. I'm going to call my scanner from keyboard, and I'm also going to call another scanner from socket. So my from socket scanner I'm going to construct using the input stream of my socket. My from keyboard I'm just going to construct in my usual way. Yeah, it is uppercase. So I have a scanner for reading from my own keyboard. I have a scanner from reading from the socket. I have a print writer for writing to the socket, right? And I don't need a print writer for writing to my display because I can just use system.out.println. But let me name this something better than PW. This is going to be called to socket. Okay, so I'm going to say, well, I have a next line coming from my keyboard. Let's go ahead and read that. So let's call from keyboard next line. And then let's go ahead and send that to the socket. And let's go ahead and flush it. And then let's read a line from the socket. So temp equals from socket dot next line. Alright, so basic while loop. Read from my keyboard, send it to the socket, and then read from the socket, print it out to my display. And that's just part of a try-catch block. And so sometimes when I'm writing code, I'll do something like the following, because you get all these nested statements, blocks of statements inside one another. Put a note on my closing brackets. This is the end of my read from keyboard while loop, right? Which reminds me that it goes up there. And what is this? This is the end of my try catch block. And what is this? This is the end of my main. And this is the end of the class. just to kind of help you know, instead of just kind of randomly typing closing brackets until it compiles. So there's the server running. It's waiting for presumably a connection on 1224, 1221. All right, so I can type over here, I can type over here, so I can say hello, and on the client side we get our hello, and over here we can say hello back to you, and it shows up on the server side. And this is fun, and so on and so forth. The problem is I'm typing in a bunch of messages over here, and I got the first message, but that's it. And it's worse than not flushing. Because if I just hit enter, I'll get my second message. If I hit enter again, I'll get my third message. Yeah. So this is what I mean when I say these things are moving in lockstep. I can only get a new message after I send a message. And on the server side, it's the same thing. I can send a bunch of messages, and I'm not going to get any of them until I try to send something over here. There's my A, there's my B, and so on. So that's our motivation for using threads. Okay, but let's do the server side into the client. So what changes over here? We don't have a ServerSocket anymore. So we're going to create a socket bound to the local host port 1221, and then we're going to get a from socket scanner and a to socket print writer. All right, and I'm going to leave everything else exactly as it is. So all I've changed, other than the mechanics of calling it a client class instead of a server class, was instead of making a server socket, accepting a connection using that as a socket, I just constructed a socket bound to port 1221 on the local host. So we can run the server over here. And we can run the client over here. I messed something up. So I said hello from client, I said hello from server, and they each got the other processes message. But we're definitely not very fluid. Alright, so I can try to send 5 messages from the server, A, B, C, D, E, and I don't get any of those until I send something from the client. So I send the 1 and I get the A, I send the 2 and I get the B, and so on. So if you can make the server code, right, you can make the client code. They basically do the same thing. The only difference is where the socket comes from that you use to build the scanner and the print writer. Server, you make a server socket, accept a connection. Client, you just create a socket and bind it to the host address in port 1221. So let's think about threading. So there's two things happening in this while loop, right? One is let me put them in the same order. All right, first we read from the keyboard, send to the socket, then we read from the socket, send to the keyboard. Okay, maybe the cleanest way to do this, I like symmetry, usually. You could make a pair of classes. Class keyboard to socket, and class, this is actually to display, class socket to display. You can call them whatever you want. But, you know, one class whose job is to do this part of my communication, just continually read from the keyboard, send to the socket. Another class whose job is to continually read from the socket and send to standard out. So you could call it, you know, from socket to socket, or read socket, write socket, or whatever makes sense to you. But I'm going to think of two totally distinct classes, one for doing each of these directions of communication. And what do we need? We need to know which socket to use. So your main method is somehow getting a hold of a socket that can be used to communicate with the other partner in this communication, either because it accepted a connection or because it bound a socket. By constructing a socket, right? So both of these threads need to know what that socket is, right? Because this is going to run in its own thread. It's got to know, if I'm reading from the keyboard and sending to a socket, what socket do I send to? So you've got a few options. You can have you know, an object sock of type socket. You got to give it a value somehow. Well, you could make a setter getter, right? And from my main method, after I construct this keyboard to socket object, right, I could call a setter and say set the socket equal to whatever socket I have, right? Or you could put it as an argument in the constructor, right? So when you construct a keyboard to socket, you'd say new keyboard to socket parentheses whatever the socket is, right? And in your constructor, you would just save that in this class variable, right? But somehow you got to pass the socket to it. And then inside here, you've got your public void run. And in here, you do your keyboard to socket. And just loop on that forever. And then in your other class, which is a socket to display, right, again, you got to have some way to remember what the socket is you're trying to communicate through. And in your run method, public void run, you just have a forever loop, which basically reads from the socket, sends out to the display. And there's, lots of ways you can do this. You don't really need to pass a socket, right? Since all we're doing is reading from the keyboard and writing to the socket, you could actually pass the print writer that main constructed, right? It can create a print writer associated with that socket by doing socket get output stream. And you could pass that print writer to your keyboard to socket class. And you could read the scanner for reading from the socket to your socket to display. There's a lot of ways to structure it. But your goal is, in your main method, well, let me just write you some commented code. You gotta write a bunch of code. So what am I calling these? So keyboard to socket, K2S equals new keyboard to socket. And I don't know, I'll just pass it the socket. And then alright, so construct a keyboard to socket object, construct a socket to display object, and each of those you pass the socket that you're communicating on. And then just start those threads. And then all of this stuff goes in the run method for each of those classes, depending on which direction you're going in. Does that make sense? Yeah.
Why did you use two separate classes?
To make it simpler. You don't need to, you can make it one, but they're doing fundamentally different things, right? So you could, if you're going to have one class, how are you going to tell it which way to communicate?
You could give it an input stream and an output stream.
Okay, and how do you tell it which one to use?
You on one of them you give it the socket, and then you give it standard out, or whichever way you want to do it.
Okay, and then just have it go. Yeah, that would be cool. So you could have a single class that just reads from a socket and sends, or reads from one stream and sends to another stream. And you could construct that twice, and one of them you could give it a socket and standard out, the other one you could give it standard in and a socket. So that would work well. And if that's simpler, go for that. Yeah?
Do sockets, so is it possible for the server to know that it's connected to two clients? Say if one client connects to the socket, is it some way to differentiate that from someone who's connected to it, the same socket in a different thread?
So, I was about to say only one thing can connect to the socket, but that's not true.
On a different thread.
Yeah. I don't think the server can tell that. I think you have to do some housekeeping to let it know. So,
on mine, what I do is whenever the client connects to it, I basically, the first thing I send them is a client ID, and then the server and the client both have a copy of the ID connected to the socket.
Okay.
I can
So-
differentiate between people through the ID.
Okay, so that's your
And
housekeeping.
then every time another client joins in, they get a new
Right.
ID.
Does that make sense?
Yeah.
Okay, that's a good way to
what
do
I
it.
was going for as well.
Yeah. All right, so let's talk about the shutdown business again. So you've got two threads. And this is, let's say this is on the client side. So you have a thread that's reading from your keyboard and sending to the socket. You have another thread that's reading from the socket and displaying it. Okay. So on the client side, when you want to exit, let's say you decide to exit by hitting Control D. Okay, so your scanner on standard end, your has next line is going to come back false. Okay, and that kicks you out of, usually it's a while scanner has next line loop. So that kicks you out of the loop. You know that the user said end of file. This thread can shut down pretty easily, right? If it closes the socket, right, then this thread should get an exception when it tries to read from the socket, which is where it's sitting. It's saying, well, socket.has next line. Once you close that socket, that should come back false. That lets you close down the connection also. I wonder if we can actually do that. Oh, I don't have it threaded, so we're not gonna go that way. So on the client side, it's pretty easy to shut down, right? You're going to be able to kick out of your loop on the thread that's reading from the keyboard because you got the end of file. Close the socket. This thing, which is trying to input from the socket, should fail immediately. So that's pretty easy. On the server side, the server doesn't exit because the server said Control D, right? The server side should not be closing out the connection. So on the server side, what's going to happen? While you're reading from the socket, and that's going to come back with an end of file, right? Socket has next line will be false. So this thread can die pretty easily, right? But remember, thread 2 is sitting here and it's trying to read from your keyboard. And unless you somehow close your keyboard, right, to cause this to fail, right, which is going to be bad when you try to start the next session. So this thing is sitting here and it's inside this while sc.has next line. And so that's a blocking I/O, right? When you call has next line, you don't come back until another line is available. And so I could set a flag in here saying, hey, tell thread 2 to exit, but I'm not going to check that flag until I come out of this call to has next line, right? So we want something like a non-blocking way to do input from the keyboard. So something like this. So I have a done flag, which is false. And while we're not done, If data is available from the keyboard, read the data, send it to the socket. If other thread said that we should exit, set done equal to true. So thread 1, when it reads from the socket and it gets an end of file, it's going to set something in thread 2, which says, hey, our connection to the client is done, you should exit this loop. Okay, so we're going to see if data is available. If it is, we're going to read that data, send it to the socket. And then we're going to check to see if the other thread set our exit flag. And if it did, we're going to set done equal to true, and that's going to kick us out of our while loop. The trick is we're not trying to read the data unless there's actually data available. Okay, so this is effectively a non-blocking read. So let me give you an analogy. Suppose you wanted to have a 5-second timeout on reading something. So you want to read input from the user and you want to only give them 5 seconds to put in whatever they're going to type in. If I just call next line, right, I can start a timer and say, you know, wait 5 seconds and then do something. But if I call next line, I'm not going to come out of that call to next line until they type something in and hit enter, right? And it doesn't matter if 5 seconds have passed and this other thread has set this flag saying, hey, time's up. I'm not going to notice that flag until I come back from my call to next line. So if you do something like this, right, you can check to see if your timer expired. And if it did, you can kick yourself out of this loop. Otherwise, you can be reading whatever data is available. So let me show you a non-blocking I/O. Alright, so we'll make a scanner that lets us read from system, from standard in. Actually, let me just do this. Let's not use a scanner. Let's make a data input stream on system.in. So data input streams have a method available called available. And available tells you roughly how many bytes you can read without blocking. Right, if I say read a byte and there's not a byte sitting in my input stream, I'm going to block until there's a byte available. So available will tell you how many bytes you can safely read without blocking. So if I want a non-blocking read, I'm only going to say read the next byte if I know there's actually a byte sitting in my input stream. So I'm going to call the available method on my data input stream and see if it's bigger than 0. And if it is, then I know I've got a piece of data available. And let's see, how do we want to read this?
Does it tell you how many bytes are there?
It tells you roughly how many bytes. It says approximately. And it's approximately because there may be more bytes available. But I'm pretty sure you're guaranteed not to block if you try to read that many bytes. Okay? But the warning is you can't use that number to construct a temporary string to store stuff in, right? An array of bytes. But you only, if you take that number and you just say read that many bytes, right, then you're okay. And
So you can keep reading 1 byte until that's 0.
you can keep reading 1 byte, or you can also use like read fully, but you can specify a length, and it will read up to there. So this is the number of bytes that you want to read. Alright, so if there's a byte available, I'm not going to be weird about it. Let's just print out the byte that we read. So here's the idea. I want to count up the number of seconds that have passed, and I want to keep displaying the number of seconds that have passed, but I also want to let the user type stuff in while this count is taking place. So let's this is going to be really goofy to try to like make it look reasonable. I don't know, let's just run it, let's see what it does. Gotta have a try catch block.
like divide I by like,
Yeah, I could make it bigger, but that's not exactly what I'm after. I really want to do this with multiple threads, but I don't want to like give away thread codes.
why not?
Yeah, I know.
Perfect block.
Yeah, that doesn't really illustrate what I'm after. Let's see. So the goal is to be able to keep going through a loop, right, without having to wait for input. So yeah, this does illustrate it actually, right? So my loop is running, it's doing its thing. I can type in input, right? And even though I haven't hit enter yet, so next byte is not going to return anything, right? I'm not stuck inside my loop waiting to read my input. I'm still doing other things. I'm incrementing I and printing it out. Now once I hit enter, right, my read actually succeeds in pulling in whatever characters I typed in, and I can see, I typed ABC and new line. But if I just did this with a scanner and I said, well, scanner dot has next byte, print out scanner dot next byte, I'd be stuck in my has next byte until I hit enter, and then I could go through my loop once and I would increment I one time, right? And this is continually going through my loop, going back to the top of the loop, incrementing I, and so on. But I'm still able to pick up input, and once I actually hit enter, I can respond to it. So that's the whole setup of a non-blocking input system, and that will help you in trying to shut down that second thread on your server side. Okay, so on your server side, if you do this with a non-blocking read, right, it can continually check to see if thread 1 has said, hey, shut down the connection. And as soon as it finds that, it can just close out its socket and exit, and then you've gracefully shut down both sides of the communication. All right, so any questions on that? All right, I think that's all I need to say on sockets and threads. So eyeball the URL class before tomorrow and get an idea of what it can do. So this is a standard class in java.net, and you can construct a URL object with a string which looks like something like this, right? So a standard thing you might put in a web browser, and it understands the protocols of HTTP, how to request pages and how to set variables and things like that.
With DA5, you said that on Canvas it says that it's due on Friday, but on the specification sheet it says on the bottom that then was weekend on Monday that the program is due.
Mm-hmm.
So does that mean it's actually due on Monday?
No, it's due on Friday.
It's still due on Friday?
Yeah.
Okay.
Worth a try, David.
What?
Worth a try.
Doesn't hurt to ask.
Yeah.
I would prefer it was turned in on Friday. Are people going to be upset if I extend it to Monday?
Absolutely not.
No, I would actually feel better. My heart would feel better.
Your heart would feel better.
You'll actually live longer if you do.
Well, yeah, but you'll spend 3 more days of that long life writing code for a programming assignment.
Learning code.
Learning code.
Instead of sending that to like Stack Overflow or.
Yeah. Okay. Yeah, I can extend it to Monday.
Yes. Peer pressure.
Yay. All right. Cool. I will see you tomorrow then.
Monday.